Welcome back. Now our spheres are moving forward, which is pretty cool, but I don't think I'm satisfied with that. Rather than just moving forward, I think it would be cool if the spheres were also turning. Now, I plan on these spheres lasting for just a few seconds before they go away, and the objective will be to find and hit those spheres before they go away. So, while they're still alive, I'd like them to be moving but also turning, almost moving in a sort of circular arc motion. Now, to do that, we can simply rotate our sphere. As it's moving forward, if it's rotating, it's going to move in a circular arc. I'd like to do that. And before I ask you to implement this, I'm going to just point out that our sphere just has a single mesh. It doesn't need to be attached to a scene component. The sphere mesh itself can be the root component. So if you want, you can take that sphere mesh and drag it onto the scene root and make the sphere mesh itself the root component. I'm going to do that. So now that that's done, it's time to think about rotating our sphere. So here's your challenge. Rotate the sphere every frame and tick according to a rotation speed. So choose how to rotate the sphere. It can be any way that you like, but do take frame rate into account so that as soon as the sphere begins to move, it will rotate as well. Pause the video and give this a try. Okay, so in addition to add actor world offset, I'm also going to use add actor world rotation. And I'm going to want to take frame rate into account. Now, your solution may have been different than mine. That's okay. That's the point of these exercises, is getting you thinking about how you would implement these things yourself. But what I'd like to do is have a rotator variable. I'm going to promote delta rotation to a variable. I can simply call it delta rotation. Now, I'm going to initialize delta rotation to, let's say, 45 in each component, yaw, pitch, and roll. But I want to take this delta rotation and scale it or multiply by delta time. So I'm going to get delta seconds, multiply it there, and this is actually what I'll be using for delta rotation. So now if I go and press play, I can see that my sphere is rotating. So it's moving, but it's also rotating, and we get a sort of spiraling behavior. So that was the challenge, and if you got this far in the challenge, congratulations. It required a little bit of thinking. But what I'd really like to do is randomize this delta rotation. I'd like yaw, pitch, and roll to be random values. And to do that, we can use some of the Unreal Engine math utilities. There are a number of random functions. If we type random rotator, we can get a random rotator node. Now, I don't want a random rotator every single frame. Calling this node every frame means each frame we'd get a completely different rotator, and I really just want the same rotator, but I want it to be random per actor. So what I can do is set delta rotation in begin play using random rotator. I can hold Alt, drag out a setter for delta rotation, and on begin play, I can set delta rotation to a random rotator. Notice random rotator has a checkbox for roll, and that's because often we don't really care about randomizing the roll for a rotator. It's pitch and yaw that's usually sufficient. So I don't need the roll. We'll just have a 0 for the roll. And delta rotation doesn't need to be initialized. I'm going to zero out the default value for delta rotation. And now every time we press play, we should see the sphere rotating in a different rotational direction every single time we play the game. It was going up that time, but if I press play again, now it's going in a different direction. Pretty cool. Now, I don't want it to rotate that rapidly. I'd like it to have a larger circular arc than this. So I'm actually going to scale this rotation by a value. I'm going to take the random rotator and multiply it. And the float that I'm going to use, I'll promote to a variable and call this rotation scale factor. I'm going to set this rotation scale factor to a default value of 0.25, and that way those yaw, pitch, and roll values will be a quarter of the size that the random rotator node gives us. So that's what I'm going to set delta rotation to. And while we're at it, we can take these variables and give them a category other than default. I'll call them sphere movement. So I'm going to set speed, delta rotation, and rotation scale factor to have the category sphere movement. Now that we're scaling that delta rotation down, I expect to see a larger circular arc. And indeed, I do. I'd actually like it to be an even larger circular arc, so I'm going to scale this random rotator down even more to about 0.05. And taking a look, there we go. Our sphere is rotating in a larger circular arc, and that's exactly the behavior that I personally want for my sphere. Okay, excellent. So now that we have functionality, before we wrap up, let's just tidy up our nodes a little bit. I don't need event actor begin overlap. I'm going to delete that, and I'm going to collapse these nodes into a function. I'm going to right-click, collapse to function, and call this initialize delta rotation. So that's its own node. And we can collapse these into nodes. I'm going to collapse these nodes here into a function that I'd like to call update location. So I'm going to collapse to function and call this update location. And I don't like this input having the name A. I'd rather call it delta seconds or delta time. The two are synonymous. And for these nodes, I'm going to collapse them to a function called update rotation and call its input delta seconds. And now our tick function looks a good deal better. And I think I'll use a reroute node for delta seconds here so that it's much more clear visually what's going on. Okay, excellent. So our small sphere is not only moving forward, but it's rotating and moving in a circular arc, and that arc is random every time we play the game. And that's going to look nice as we spawn multiple spheres in our world. Great job. I'll see you soon.